hopefully you can see the screen, that we can just continue with session 2. So last time we have started with session 2, and we've started to look at the stem and leaf. So let's just quickly, and we've looked at a different type of question that they can also ask in stem and leaf. So let's just continue with that, and then we'll get into study unit 3 just after this. So basically, the different ways that they can ask something like this in the exam is, the first one was nearly every time they're asking you some of the information that is related to that. So in the second question, you needed to do something with the data to show that stem and leaf. And in the third option, again, they give you data, and they ask you what are the different, to look at the different options and then decide. So let's look at this data and what they tell you in the data, so that you can get to the right answers. Okay, so the first thing that they tell you in this is that you're working with a 2-digit integer. So when it's a 2-digit, that first value will be 20. Okay, so we know that the first value is 20. So let's, even before we do anything else, okay, so when we look at the first option, so what they've done is to write 022711359. So we know that that one is incorrect because your first value should be 20. So then we look at your second option. Your second option is not a 2-digit, it is a 1-digit, because it's 2.0. Okay, so all the data array is correct, but it should not be 2.0, 2.2, 2.2. Okay, so this one they wanted to nearly catch you out, because the data seems correct, but it is important that they say 2-digit. Okay, so that can't be the correct one. Okay, so let's look at the next one, 20. Okay, so that might be correct. Option 4, 20, that might be correct. Option 5, starting at 2, definitely not 2. I just want to see what is happening on the chat. Okay, nothing. So when you can just raise your hand or put something in the chat if you want to ask. Okay, so if you look at this answer, we're looking at 2 as the possible to start off with, and it can't be 2 because your first option needs to be 20. Okay, so the option set of 5 is also incorrect. So we're basically sitting with 2 options available. Okay, so 20, 22, another 22, 27, 31, 31, 35, 31, 31, 33, 35, 39. Okay, so option 3 will be the correct one. What's the difference between option 3 and 4 is the 22 that was a duplicate here, they didn't show. So there should have been a 22, so they didn't show that 22, and also they didn't show the second 31. So again, when you run through the data, it is very easy to make the mistake of saying, but there's 20, 22, 27, and forgetting that there is twice the 22 and twice the 31. Okay, so that is why option 4 was also incorrect. So this is just another way that they can ask you to, in the assignment or in the exam, to do it. And as with stats, they nearly want to try to catch you out. And that is nearly a very easy way to catch you out, because the wrong one of 2.0 was, if you would have gone through it, you might have chosen that one. Okay, so that is one of another way of a stem and leaf. So the traditional question that they normally ask you in their stem and leaf is this type of one. So we'll see in the next 2 slides previous exam papers as well that was used, but here they tell you it is ages of people. So when they say ages, they don't need to tell you it is 2 integer or 2-digit integers, because you don't get a 2.5 age. So ages means that your lowest number is 25. Because it's age, we know the highest number or the highest age is 61. Okay, so let's look at what they also then ask us to do. Incorrect one. The smallest age in the sample is 25. We've identified that, so that is correct. Most ages in the sample are greater than 40. Okay, so now we need to look. That is 40. Greater than 40 must be bigger than 40. Okay, so they are telling us that most of the ages is bigger than 40. Okay, so with this, the only way nearly to get to that is to count. You can look at it, you can maybe say, but I won't know until I basically count the numbers. So let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 of your values is below 40 or 40 and below. We want to see greater than 40. So we know in total there is 40 workers. So if below 40 and below is 25, we know that more than 40 or greater than 40, there is 15 ages. So not most of the ages is greater than 40. The least is greater than 40. So we know that option 2 is then incorrect, because there's only 15 that's greater than 40. There is actually 25 that's less, 40 or less. Yes, question.
Sorry, Jane. Do you mind actually, after everything, just to explain how we get the sample which is greater than 40, because I think I missed that part.
Okay, cool. No problem at all.
Thank you.
So let me do it this way again. So they ask us the sample of greater than 40. So then I look at the data. So data starts at 25. That one goes up to 29. We start with age 30 again, up until age 39. Here is age 40. There's another age 40, but they want more than 40. So greater than 40 can also mean more than 40. Okay, so we want more than 40. So 41 starts with this number here. So then basically I could have just said, okay, so let's count how many is more than 40. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 numbers is more than 40. We know in the sample, because they've told us the sample in totality is 40 workers. So if 15 is more than 40, we know 40 and below is 25. So the majority of workers is actually younger than 41, and not, or 40 and younger. So that is why we can say that that one is incorrect, because not most is older than 40. Is that
Okay, thank you so much.
cool?
Jim,
Yes.
I'm still confused on that one.
Okay,
Because
so
I can see 1, 1, 1, 6, 6, 6, and
okay,
8. But
so
when I count it, it makes 12 or 11.
okay,
Then
so
I don't know where I miss, like, yeah.
perfect. Let me quickly do that again. So please ask the questions, because I think that is important. So let me take that out. So I'm only going to focus now on those ones. So let's see. So there's 141, but there's a second 41. There's a third 41. There's a fourth 41. So there's actually 4 41s.
Yeah.
So let's then see. There is
46.
346. One 48,
Yes.
149. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 that are in the 40s. Okay, so now we also need to, there's 2 50s.
Okay.
There's 151,
Yes.
152, 153. So in the 50s, there was 1, 2, 3, 4, 5. And then there's still a 61 as well, which
Okay.
were 160. Okay, so then, so 951, so that in totality gives you again the 15.
Okay, now I understand. Thank you.
Cool. No problem at all. So please, if there's anybody else that needs to ask a question, please do. Okay, so let's look at the next one. So the mode of the distribution. So mode, and it's actually only in chapter 3 that we do mode. Mode is the number that happens the most. Okay, so the number that happens the most. So let's take all of this away and let's see which number happens the most. So in the 20s, there's a 26 that's twice, there's a 28 that's twice. Okay, so let's hope there's a bigger number or more, happens more. In the 30s, there's a 33 that happens 3 times. So that might be the number. But 35 is only twice, 36 is only twice, 37 is only twice, 38 is only twice, 39 is only twice. So at the moment, we've got that 33 is the one that happens the most, and it's 3 times. So let's go into the 40s. 40, only 2. Okay, so let's see. 41, 1, 2, 3, 4. 46 happens 3 times, and then 50 happens twice. So we know then that 40 actually is the number that appears the most in this data set, and it appears 4 times. Okay, so that is why 41 is the mode, because it happens the most in the data set. Okay, then let's look at the next one, the range. Again, question from study unit 3 is the range is always the biggest number and you subtract the smallest number. So we know the biggest number was 61. We know that the smallest number is 25. So we subtract those two numbers from each other to get the range, and that will be 36. Okay, so we're happy that the range is 36. Okay, the median is the number that is in the middle. Yes. Is there a question? Okay, so let's go on. The median is the one in the middle. So again, let's look at the number in the middle. So we know that there is 40 workers. So we need to get the number that is around the number 20 nearly, because 20 is in the middle. So let's look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20. Okay, so the number between 20 and 21 will give us the number. There's also a formula to work that out. So the formula to work that out is n plus 1 divided by 2. So where that number is in that position, so let's look at, it would have been 40 plus 1 is 41. 41 divided by 2 will give me 20.5. So we've seen that that position is position 20. That position is position 21. Position 20.5 is in the middle of those two, but because that is 58 and that is 58, there can't be anything between 58 and 58. So we know that then the median is 38, because you can't have anything else than 58. If it was, say, between 58 and 59, then we would have said, okay, what's in the middle of 58 and 59? In the middle of 58 and 59 would have then been 38.5. Okay,
Sorry,
so
Jen,
yes,
again, Jen,
yes.
I'm confused on this one. Why did you choose 8 out of all the numbers?
Okay, so let's explain again, and let me explain it from the other way around. Okay, so there is another question. So quickly ask the question if it is maybe the same. I just see another hand. Okay, so
I was just gonna ask for Veli's Siwe to switch off her
oh,
video. It's causing a bit of a distraction. Veli
yes,
Siwe.
sorry. Okay, cool. Yes, please just switch off all videos. Also for data purposes, it's better if videos are switched off. Cool. Okay, so the other way to look at it is when I need to find the median. To find the median is we get it through the formula of n plus 1 divided by 2. So, and I've written that on it's also on the PDF that I have sent through. So I'll just send through, it is on a WhatsApp group as well, the formulas that is important. Okay, so we have the n plus 1. So n they've given us is the sample. We know the sample is 40.
Yeah.
So we need to, according to the formula, say plus 1 divided by 2. So that is 41 divided by 2, which is 20.5. So what this tells us is that at position 20.5 of the data, we will find the median. Okay, so then the easiest for me is to say, okay, well, 20.5, I don't have the faintest idea where it is, but I can at least count. So let me count up until 20, and then the next value will be the median. So that's my first one, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so 38, that 38 is my 20th number. So I know then the next number is my median. And in this instance, it was also 38. By fluke, 38 also, so it's not always the same number, the next one. So in this instance, it was just also 38. Okay, is that a bit clearer?
Yes.
Okay, awesome. Cool. Okay, so what is very interesting about the next two slides is this was a question in the 2018 exam. So and then it was still a semester subject. So you will see that the May-June 2018 exam question and the same year, the August-November question, exactly the same. So they give you exactly the same data. They just had the questions that they ask around the data was different. The reason I show you this is because in the way your exam will be set up this year is that, and that's the same with your assignments as well. You will get the assignment is a question. What will happen is that there's 3 or 4 different assignments nearly running in the background. The same will be for the exams. There's 3 or different exams running in the background. So you can have the same data set, but you can have different options. So this is also why they do it, is so that you don't in the exam message your friend and say, okay, answer number to question 1 is option 4, because it can be a different set of questions that you are getting. So that's just why I want to show this to you. So let's look at the question set. So which is incorrect? So the range is 50 is the first question. Again, how do we work out range? Maximum number minus the minimum. So let's see at what is the maximum. Okay, so the maximum number is 86. The minimum number is 36. So 86 minus 36 is equal to 50. Okay, so the range is 50, is on both sides is correct. So let's look at the next question. The fifth largest value is 50. So let's look at the data set. The fifth largest value. So fifth largest is 1, 2, 3, 4, 5. Okay, so the fifth largest value is 50, so it is 50. So for that one, oh, okay, so now I made a mistake. Huh. Okay, so largest, the fifth smallest. Okay, so the fifth smallest value is 50. The largest, I need to count from the other way. So 1, 2, 3, 4, 5. So the fifth largest number would actually have been 80. Easy how to make that mistake because I was just counting from the bottom, but the fifth largest number is sitting there, so that is supposed to be 80. The fifth smallest number is 50. Okay, so that one is correct, or in that exam that one was correct. In this exam it was the incorrect one. So let's just also look at where this one is wrong then. There are 33 numbers, so basically they're asking us what is the sample? What is the sample size? The way to get that is just to count all the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 8, 30, 31, 32, 33, 34. Phew. Okay, so now I'm not getting the same, so let me just do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at that point we have 30, 31, 32, 33. Okay, so the numbers are 33, which is correct. Okay, mode, yes, there's a question. You can ask a question. I can't see who it is, so just, you can ask. Okay, so let me just continue until mode is the number that happens the most again. So let's just take some of this away so that we can see. Okay, that's one number. Okay, so 51 happens twice. 55 happens twice. 64 happens twice. Okay, 70 happens 3 times. Okay, so those numbers happen twice. 70 happened 3 times, so 70 is the mode. Okay, medians is 64. Median is 4. Okay, so that one will definitely be wrong because our smallest number is 36 and our biggest number is 86, so it can't be 4. But let's just first work out the median. Median is the one in the middle. So the one in the middle, so let's look at this 33 numbers. So one in the middle is around 16, 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So between 16 and 70 again, like in the previous one, the one next to it is also 64. So the median is then 64 because there is nothing in the middle between those two numbers. Okay, we'll do one more, but let me quickly, any questions on this so far? So what we've seen with the stem and leaf, at the beginning of the questions, it was basically looking at the ways to look at your data as in chapter 2. But as we continued with the questions, it's nearly a combination of chapter 2 and chapter 3. Because in chapter 2, it's only the visualization of the data, but in chapter 3, it's all the data principles of of mean, median, mode, variance, standard deviation. So at least we haven't done that in your stem and leaf. Okay, so your next question, and this I've seen a lot in last year's assignment, so I'll definitely just making a note so that I sent you last year's assignment 1 on the WhatsApp group as well. I'll do that tonight, but I'll send you that. So what is important about this is that we need to know what is relative frequency. So luckily in that PDF document, the summary that I've sent you guys on WhatsApp, we have done something like this. So relative frequency is basically looking at, you need to get the number and divide it by the total sample. Okay, so they ask us A and C. So we need to say 160 divided by 500, and that will give us the relative frequency. Just to show how they are nearly want to confuse you in a sense, they give you the total sample, they give you the 160. So if they have asked you just frequency, then your answer would have been 160. Because we're asking relative frequency, you need to work out what is 160 divided by 500. And that answer will most likely be 0.32, but let me just quickly check. 160 divided by 500 is 0.32. Okay, so in this instance, that would have been your correct answer. They have asked in the second exam of that year, looking at the same data, what is the relative frequency of a DA? So the relative frequency then of a DA is just the 246 divided by 500. So again, you would have seen they give you the sample, they give you the relative frequency of something there, so we can check now what that is. They have given you then the frequency of the DA. So that is the frequency of a DA, but you want the relative frequency. So it is 246 divided by 500, which gives you 0.0492, 0.492. And again, how easy to make the mistake with this one. So, and you want to start with 0.4 sometimes, and then you see, oh, okay, that was actually very close. They just swapped the two numbers around, but that is then also incorrect. Okay, there is a question, there's a hand. So please ask.
Hi, Jean. I just wanted to confirm that are you saying the formula for finding relative frequency is the frequency divided by the sample?
Yes, yes,
Thank you. I wasn't
perfect.
sure if I've got that correctly.
Yes, perfect. So, and I like why you now ask that, because if I didn't tell you the sample size is 500, what would you have done? Then you needed to say, if I needed to find out the relative frequency of the ANC, but it is 160 divided by the sum of all three of them. Okay, so actually thank you for that, because sometimes we know the formula, but if I didn't include the sample of 500, it is the sum of all those numbers that would give you the 500. Cool, so you spot on. Any other questions on this? Okay, so let's then use the rest of the time to start with session 3. So I'll share these presentations as well. So I'll also save it as a PDF and send that through. And then from next week, I'll beforehand send you the presentations that you also have that if you want to make notes on it. Okay, so we would have started with this last week. So let me just, can you still see the presentation now, session 3?
Yes.
Yes.
Okay, cool. So let's, session 3, it's study unit 3, so let's do this. Okay, so basically in study unit 3, there is, if I look at what we will cover, it is your central tendency, which is in the middle, and things around the center of the distribution. So just for that, the things that we will always look at in central tendency, or they can call it central of the location, is mean, median, and mode. So that's the 3 things that we will cover under that. Mean is just your average. So the mean is just another word for average, and there are a formula for that as well. So it's basically taking all the values that they give to you and divide it by the number of values there is, or divide by the sample size. So that is your mean. Your median we've covered in the stem and leaf, but what makes it sometimes difficult and confusing in other diagrams is your median is always, you get it from your ordered set of data. So stem and leaf was ordered, so then it was easy for us to say, okay, we go to the middle of that data. If a data is not ordered, you first need to order the data to get your median then, which is in the middle of that data. Okay, let me see. There's a question on the chat, but there's also a hand, so you guys can quickly ask.
Can you please kindly just repeat on how we get the mean?
Okay, cool.
I think I missed you there.
Perfect, no worries. So the mean is the average. So the mean is the average, and the average is just you add all your values together and you divide it by the number of values that there is. So if you have, let's quickly, I want to get to, so if we needed to work out the mean here, so we will But the mean here would have been, you sum all the values and you divide it by how many there is. But a practical example I'll show you now. I'll show that now in a practical example for you. Just want to see the question on the chat. Quick question, what is lower class and upper class limit and how do we find it? Okay, so that is an interesting one, and I think that is supposed to be with the previous data. Okay, so let me quickly go back to, I'll make a note that we just go back to that one if we have about 5 minutes left in the session, but it is on the previous, on study unit 2. So I'll definitely go back to that and show you how to do that. Okay, so let me just quickly get to then the mode. The mode we've done now in the stem and leaf as well. And the mode is the number that happens the most. Okay, so that is the three things around measures of central tendency, mean, median, mode. Then what we then get is, so after we've done the mean, median, and mode, they will sometimes ask us, so how is that distributed, or how is that dispersed, or the variability in the data? So then we get to things like the range, because we want to see what's the difference between the biggest and the smallest number, because then the rest of the data lies between those numbers. We want to see the variance. So the variance basically tells us how each number differs from the mean. So if the mean was 28 and there's numbers around it, it basically wants us, or it works out how it's different, the numbers to the mean. Then the sample variance is basically a subset of the population. So if we know the population variance, the sample is always a subset of a sample. So the formula is very similar. In most of our instances, we will work with a sample because we will always work with a subset of data. If not, they need to tell you that we are working with a population. So when we look at the data, we will always assume we're working with a sample unless they tell us we're working with a population. Okay, and then the standard deviation, nearly one of the last ones that we look at, it's just nearly the square root of the variance. So the variance that we've calculated, it is the square root of that. Okay, so that is central tendency and nearly the dispersion of the data. Yes, question.
Can you please explain again the variance?
Okay, so let me show you on this one, on the example, nearly how we will look at variance. So to get to variance, let's order the data first. So the smallest is actually 26, then it's still 27, 28, then it's a 30, a 31, and a 51. Okay, so what the variance is going to work out, it's going to work out for us, and let's work out first what is the average. So let's see if that sample is actually correct and what it should be. So how we work out the sample, it is the sum of the values. So let's just say the sum of the values of x divided by n. So it is 26 plus 27. So we need to then say plus 28. I'm not going to write everything down, but until the last 31, and we divide that by 6 because that is the sample size. Okay, so let me just work that out on a calculator. 26 plus 27 plus 28 plus 30 plus 31 plus 31. So that answer is then 173 divided by 6, which is 28.83. Okay, so the sample mean, we needed to get the correct one, so the sample mean is actually wrong. But what the variance then does is to say, but how does these other numbers differ from your sample? So the variance will say, okay, your sample average is 28.831. It lies somewhere there. It's going to take all the other numbers into account, and then it's going to say, okay, but how does those numbers differ from 28.83? And with a calculation, we will then get to a variance. So the variance is just nearly a calculation of how different the data is towards the mean. Does that help a bit? I know it's still a bit theoretical and high level, but does that at least help a bit to nearly explain what the mean wants to do? What the variance wants to do?
I think I have a slight example, a little idea, sorry.
Okay,
If I get confused, I will text you.
Okay, cool. And I think somewhere, not today, but we will probably then on Saturday need to work it out somewhere. Else I will really, it doesn't seem like it. So else I will just write out the whole process. So what I will do for you, because that will help the rest of the guys as well, is to, sorry for the spelling, but this is for myself to make a note. So I will use this example and write out the process how to calculate the variance. Then you can see with that number what I want, what I try to explain. But I'll do that for you guys, just to do that in this example. So I'll do that and I'll post it on the WhatsApp group as well. Okay, so let's quickly look at the other options in this question in any case, and then we can go back to slide 5. So the range, the range is always biggest minus the smallest. So it is 51 minus 26, which is 5. The median is 28. Okay, so we wanted the correct one, so that would have been our correct answer. So let's just highlight it, so that would have been correct answer. So let's just see. So the median. Okay, so now look at this 26, 27, 28. So here we have 3. Here we have 3 numbers to this side. So your median must be in the middle. This time we don't have another 28. So what is the number that is between 28 and 30? Yes.
Hi, Jean. So it will be, seeing that in the entire sample we have 6 numbers, then we're going to take the 2 which are in the middle That's 26 and 30. We add them up together, and then we divide by 2. So that's how we come up with the median.
Okay, so just remember, when you work out the median, you need to work on the order data. So
Oh yes.
so the two
Sorry, I forgot
numbers,
that. Yeah.
yes. So the two numbers, but perfect. So the two numbers is 28 and 30. You add them together, divide by 2, which will give you 29.
Yes, but in this case now it's not ordered, right? So
Yes.
we first
So
need to order. Okay, no, it's fine. You can
so
carry on.
see, if you used the non-ordered data, you would have gotten 28.
Yes, absolutely.
So that again is so, and a lot of the questions you'll see, and even if you're in your assignments, it's nearly, if you made a mistake, it is nearly because it was a correct answer for something. And I think that is, you guys will see in your assignment 1 as well. It's nearly, it doesn't matter nearly what you work out in the process, there is nearly a correct answer. So if you now did median and you worked with the unordered data, you would have said the 2 in the middle, and there's the answer. So just be very careful in the stats. I don't know how it is in some of the other subjects, but the stats subject specifically, it's very easy to make the mistakes because of nearly things that they give you to catch you out. The mode 30, so yeah, at least the mode, we know it's the one that happens the most, which is 51. So the mode was not 50, it should have been 31. The distribution is symmetrical. So for distribution to be symmetrical, it needs to be bell-shaped. And with those numbers here at the back, so what I sometimes do for myself is also I stack the data just to see if I can draw a graph over it. So 26, 27, 28, then there's a gap, then it's 50, then it's 51 and 51. So if we draw a graph over this, your graph will look like something like that. And for it to be symmetrical, it needed to look something like that. So this is just for me a weird way of looking at it, but to see, okay, but this and that is definitely not the same. So definitely that one is incorrect. It can't be symmetrical just because of that bump there at the end. Okay, so this was the first one that we nearly did on median mode, mean, a bit of symmetry, and then they brought in a range. What you will see in the exam, but also in your assignments, is in the assignments there will be a few questions on definitions and a few practical. So one of the things that we see in your definitions is they like it very much to ask about the mean, median, and mode, and things that you can see around that. So again, the summary that I sent today on chapter 3, keep that with you. The one that says on the symmetry, I've written in there about the mean, median, and mode as well. So let's just look at these options and what we need to find out. So they tell us the distribution is symmetrical when. Okay, so symmetrical is when the mean, median, and mode is all equal. Okay, so that is when it is symmetrical. So we know option 1 is correct. But let's just look at some of the other things, because we use the sample to conclude about the population. So yes, we do use sample to conclude something about the population, but not, it doesn't say that something will be distributed symmetrical. So nearly the statement is correct, but not to say that is why something is symmetrical or not. Each observation in a sample is likely to be selected. Again, that is something that is true, but it has no relation to if something will be symmetrical or not. The value of the mean, median, and mode are not equal. Okay, so that is definitely just wrong, because it should be. We are able to calculate the mean and the standard deviation through the calculator. Again, yes, we can. There is nothing wrong in this, but that has nothing to do with if a distribution is symmetrical or not. So 3 of these statements was actually, in a sense, it's not false, it's not a false statement, but it has nothing to do with what we want to find out, and that is if something is distributed symmetrical or not. And I think, again, it's very easy nearly to be in the exam in a rush, because timing is very quick in the exam for the questions, and you just see a distribution, yeah, the sample, or the other one, or maybe even the other one, because if you quickly look at it, it could have nearly been some of the other questions or answers as well. Okay, so let's stop here. I just want to quickly go back to the data and the data frequency for the lower class and upper class limit. So Sam, I hope you still on the call, so that we can just
Yeah, I'm still here.
okay. So let me quickly. Okay, so there is not data. So let me do this. Okay. So what sometimes will happen is they will tell you that you've got, so let's say the ages of people. So what they can do is to tell you or give you a data table, and let's say that is, there is 5 people within that age group, there's 6 people within that age group, and there's 5 people within that age group. So that can be one of the ways that they can ask you a frequency table, where that is then the frequency, and they can ask you certain questions around that. Then what they can sometimes ask you, what is the lower class limit, what's the upper class limit? So what would you have said in this instance is your lower class limit, and what is your upper class limit? So Sam, sorry if I put you on the spot, but I just want to quickly see if I need to explain it in a bit more detail.
I would have said 5, 5. 5 for the lower and 5 for the upper.
Okay, so you would have gone to the frequency. Okay, so what we actually want you to look at is this data set, or so this will be your lower class limit, and this one will be your upper class limit. Okay, so it basically looks at, it basically looks at that is your lowest class, because that is your lowest ages. This is your highest ages. So it basically refers to nearly how your distribution is. So what they could have asked you, and let's rephrase it because it's difficult to ask this in a multiple question. But so those 5 ages could have been something like that. So that could have been the ages. There could have been 6 ages there. There could have been 5 ages there. They could have asked you to say, but how are you going to divide it into classes? And when you nearly look at all the data, you will say the lowest one was 11, the top one was 40. So we can probably divide that into 3 classes. The lowest class will be 11 to 20. The middle class will be 21 to 30. And then your upper class will be 31 to 40. So that is if there was 3 classes. It could have been that there's 4 classes, which is maybe weird classes of 11 to 18, 19 to 27. I'm definitely now just making it up. And then maybe even a 36 to a 43. So then that would be your lower class, and that will be your upper class. So it's always nearly below the high.
No, I'm actually sorted now because
Okay.
I saw something like that in my assignment question, so I was a bit confused.
Yes, so and that's why I want to share the assignment of last year tonight still, because last year there was a whole on the frequency table there was nearly 4 or 5 questions where they had the original table, and then they had some of the mean, median, and mode around that. They had standard deviation and variance around that. They had, like you now said, the classes around that same data set. I think they had the data set, and then they also nearly created a frequency distribution out of that. So that is why I want to share that assignment as quickly as possible, that you guys can just get a feel of what will be in this assignment. I don't know if it is even the same questions. I don't have access to the first assignment. I will only, as tutor, get access to it afterwards. But I will share last year's assignment because it might give you good tips and things like that on what to prepare for in the first assignment. Okay, so that's it for this session. We'll just continue on Saturday with the next. So on Saturday we'll definitely just continue from the study unit 3. We'll finish study unit 3 because again it is around the median, the mode, order data, and then the Q1, so how to work out Q1, Q3, your interquartile ranges, because it can be that there's a question around that. The same that we can work out the interquartile range. And I know last year in your assignment 1 and in the exam, there was a box plot, even though it's very limited in your study guide in the book. So I just want to then cover the box plot as well. But by Saturday, we will then be finished with what is needed for assignment 1. Okay, cool, everyone. Have a good evening further. I'll share the recording as quickly as I can on